Hello everybody. In this video I'm going to do memory analysis on a memory snapshot that has been taken from a Windows XP. This machine has been infected with R2D2 malware, and we want to see how memory analysis can help us to understand what has happened on this machine. You can download the the memory snapshot from Volatility Foundation GitHub project, and you can follow our analysis later yourself to understand how volatility works and how it can help you during the analysis. Looking at the OS version here, we already know that this is Windows XP Service Pack 2, but if you don't know that, you can use image info plugin in volatility to find those details. Volatility comes with a lot of awesome plugins, and each of them analyze the memory snapshot from one aspect. So you can use them during your analysis. For example, here as you can see, it identified that probably is Windows XP Service Pack 2. If you want to find the list of all of those plugins, you can just use -H to list all of these awesome plugins. During memory analysis, I usually take these 4 steps. First, I look at the processes that has been executed. I check that if they are legit or not, if there's something off there or not. In the next step, I look at the network connection to see if we see any, for example, reverse shell or this sort of things. And then I look at code injection and hooks. Uh, for example, hooks, it shows that a malicious driver has been installed and there is a rootkit on the system. There are different also sorts of code injection that you can also read yourself. That's really helpful. Memory analysis can really helpful in detecting these sort of things. Okay, so the first step is looking at the process. I use PS3 plugin to list the process tree, and here you can see all the process executions. For example, this is Adobe Reader. It suggests that the PDF file has been opened. We see a cmd.exe. Later we can check which command has been executed. And also we see a couple of system related processes. In order to analyze these system processes, you can use poster published by Sans, which is called Hunt Evil. It's free, you can download it from the website. It lists all the image passes, parent processes, all the details of the processes, and you can compare it with what you see in the machine, and in this way you can find out if something is off or not. For example, for CSRS we see that the SMS.exe should exist, and also start time we see that it seconds of the boot time should this process starts. If we go here and check it, we see that the SMS.exe exists, and the time that it is started also shows that it's about the boot time. So all normal here. We can also look at, for example, lsas.exe, the parent process PPID. We look at it is 632, which is winlogon. And if you come here and check it, lsas, the parent process is winInit. So there is a discrepancy here. It could be because of the Windows XP is old, or because this process is suspicious. You can dig into that later. Moving from that, we see a cmd.exe. I want to check if to see which commands has been executed. I use command scan plugin to see the executed command. sc query malware, which probably the first one is a typo, and then we see this one. There was a query to a service called malware, so we know that this service probably exists. You can use another plugin that give you more details of the output of the console. For example, here you see the first one, which was a typo, failed, and then the other one give you the more detail. We see that this service actually exists. It's a kernel driver, so probably we have a rootkit on the machine here. But even if you want to see more detail of this service, we can use another plugin which is called SVC scan, service scan, and then we grep it for the malware because we know the name of the malware, and we can see more detail, for example, the binary path. So far we know that this command has been executed. Usually attackers gain foothold on the machine based on the user's activity. For example, by user downloads a file, execute it, and then they gain the access. So it's important to check the history of the browser to see if we can find anything interesting there. I use IE history plugin here. As you can see, this exploit.pdf has been downloaded. Probably that's how the attacker gained the foothold on the machine. So far we've done some process related analysis. We see that cmd.exe has been executed, the service has been queried, probably there's a rootkit here. We want to move to the next step, which is a network analysis. I want to use another plugin which is called ConScan to see a network connection on the machine. This is a classic way of getting the reverse shell. So from the local host to the remote host on this port, probably the attacker is listening on this port on his machine, and they use probably Netcat or Metasploit or other tools to get this callback and probably get a shell on the machine. If we look at the PID, the PID is 1956. So we want to see which process started this network connection. 1956, this is explorer.exe. Explorer.exe is used by user to open file, this sort of thing, from the graphical user interface of the Windows. So you don't expect any network connection like that. So this is definitely suspicious. We need to dig into that. I want to start with listing a DLL of this process. I use DLL list and -p with the PID of that process. Probably something has been injected in the process, and that's how the attacker is able to initiate that connection. Usually when attacker gain a foothold and run their code, they migrate to a non-processor so they can hide there. Probably this happened in this case. These are the DLLs of the explorer.exe. We can dump these DLLs, analyze them, or we can compare the list with the normal DLL list that explorer.exe uses. That's what I've done. Let's see. So I listed them. This is this is the process DLLs, and then I listed the normal DLLs from the explorer.exe in a Windows XP Service Pack 2. And I want to compare these two to see if there is any additional DLLs in the process DLL of this machine. So I cat process DLLs, and I want to exclude normal DLL. So here I exclude it, and here we see a DLL. So this DLL exists in the process but not in the normal DLLs. Probably this is suspicious and we need to dig into that. What I will do in the next step is that I want to use DLL dump plugin to dump all the DLLs of this process. I put it in the dump directory, so all of them are dumped in my disk. This is a suspicious DLL that we found, and it's dumped with this name. So here it is. So we want to check this DLL. We can do reverse engineering on this DLL. We can upload it in VirusTotal or Sandbox to analyze it. I already uploaded this in VirusTotal, so I just search the MD5 of this file. I don't upload it again to just save some time. As you can see, 53 AVs marked this as suspicious, and even some of them could detect the type of the malware. And you can see that this is a backdoor. If you go to the community section, you can also see that this is a German malware known as Stats Trojan, and even there is a PDF file explaining all the details of this malware. I move forward and I also uploaded this in hybrid analysis to do some sandbox checking to see if we can find anything interesting in the sandbox. I don't want to go to the path of reverse engineering because this is out of the scope of this video. So we see a IP address there. It suspicious APIs has been imported. Create a service. We already see that the service has been created. There are registry related activities there. It's a long list. We can you can go through that yourself. Also socket, which shows that this network connection has been executed. You don't see this sort of thing probably in the normal uh, explorer.exe. Okay, so we have some ideas that okay, this DLL is suspicious, this malicious. We ran it in VirusTotal and also Sandbox. We can go to the detail of this sandbox analysis. Here you can, for example, see the interesting strings that found from this DLL. Let's take a quick look at them. At that, we see a Skype.exe there. That's suspicious. We see a Yahoo Messenger there. That's also suspicious. Let's move forward to see if we see anything else. Firefox we see. So we see browsers and messengers related strings there. Probably this has been used for monitoring user activities in the browser or the messengers. So by just doing this sort of analysis in the sandbox, we got some ideas what this DLL does. That's very interesting. I want to move forward to the next step, which is code injection. There is an awesome plugin which is called malfind that automatically find this sort of injections. You can just run it and then later look at the results. WinLogon is suspicious. Again, WinLogon is suspicious. Couple of injection and suspicious activities have been found in WinLogon, and also we see a csrss.exe which is suspicious. Interesting. We can dig into that later if we want, and also we can move forward and check the last step, which is hooks. So we can use different plugin. One is SSDT. SSDT stands for System Service Descriptor Table. It basically is a translator between userland and kernel table. Usually NTOS kernel and Win32 is normal, so I exclude them to see if something is off there. Nothing has been found. There is another one plugin which is called API hooks that automatically detects the hooks. I'm not going to run it because it takes some time, but I ran it before. It didn't return anything interesting for me. So these 4 steps that I explained, you can take to do the memory forensics. For this particular case, we've seen suspicious processes. We checked the DLLs. We compared the DLL with the normal DLLs, and we found the DLL that is suspicious. There are other plugins there that you can use. For example, registry related plugins. First, I use a Hive list plugin to list all the Hive related details. Here you can see them. If you want to use one of them and search inside them, you need to use their virtual address there. We know that there is already a service, so probably we can find that service information in registry. You need to have some basic knowledge of registry in order to search in suspicious locations, the ones that usually attackers use to gain persistence or hide in the system. For services, you can find it in system. So this is a virtual address that you need to use. I put it after -o, and I search for the name of the service that we already know. So if you, for example, run this command, you can see the details of this service in the memory. So this image, this driver has been loaded by this malware. So this is also suspicious. Maybe we want to also dig into this file because probably that's a rootkit. There are many ways that attackers can gain persistence. You can read about that and see how they hide they use register for that. One of them is app init DLLs. What it does is that if you put a DLL there, here we can see Windows operating system have the functionality to allow nearly all application processes to load custom DLLs into their DLL space. So if you put that in this address, it will be loaded with all the other processes. We want to check this one. Let's see which the path. The path is in software. So let's check software. This is the virtual address that you need to use. Okay, let's see. I put it here, and we need to also take this part of the registry address. Okay, here we go. So let's see if this technique has been used or not. Okay, we see that app init DLLs, and this is the DLL that we already know. This is the suspicious DLL that we found in the explorer.exe, and that's how probably this DLL is loaded in our processes in this machine. Okay, so we also saw that how registry can help us during the analysis. Usually, analysts call a malware based on the strings that they find in the malware. So let's check this DLL to see we can find this string there. I already dumped this DLL, and if you can recall, this was the name of the DLL that has been dumped, and I want to grep it for R2D2 to see if this string exists there or not. Okay, it's there. Probably this is one of the DLL libraries that has been loaded, and that's why they call it R2D2. Okay, let's wrap up what we've done. We introduced four-step approach for memory analysis. We checked the processes. We saw cmd.exe. We saw that the service has been Windows service has been queried. In cmd .exe we found those information. We checked network connection. We saw that reverse shell. Then based on the PID, which we realized that explorer.exe initiated that network connection. We dig into that, the DLL of that explorer.exe. We found a suspicious DLL, and then we used VirusTotal and sandboxing to analyze that. We could also use reverse engineering to get into the detail of that DLL. We use malfind to check code injection and API hooks, and other plugin to check system service descriptor table for finding the rootkeys and hooks. And in the end, we know that we checked the registry, and we found rootkit indication there. And also the attacker used well-known way to gain persistence, and we could find those details in app init underlying DLLs. Hope that you enjoyed this video.